Alright guys, so yesterday you reviewed completing the square. There are 4 techniques for solving quadratics. We've looked at graphing. That was the first technique where you found the x-intercepts on the graph. We looked at factoring, so that's where you used grouping, perfect square trinomials, difference of squares, and the factoring technique involving the magic x. And then we looked at completing the square. So the final technique for solving quadratics is called the quadratic formula. Graphing and factoring are techniques that only work sometimes. Completing the square and the quadratic formula are techniques that work all the time. So of the 4 techniques, the quadratic formula and completing the square are probably the 2 most important for usage outside of this unit and as we continue to progress forward, or for those of you considering taking physics at any point in your future years, you will use the quadratic formula in physics a lot because the quadratic formula allows you to see both the time at which the object reaches its max height as well as where an object hits the ground. So the quadratic formula is an important technique. In order to understand the quadratic formula, we have to use something called the discriminant. The discriminant is a part of the quadratic formula, and today we're going to focus on the discriminant and what it does. So the discriminant is a part of the quadratic formula that determines the number and type of solutions to a quadratic equation. So here is our quadratic formula. In standard form, you have ax squared plus bx plus c equal to 0. So this represents the standard form of a quadratic formula. So that's standard form of a quadratic formula. The quadratic formula says that we take negative b plus or minus the square root of b squared minus 4ac all over 2a. So this right here in that yellow box is your quadratic formula. The a, b, and c come from standard form of a quadratic equation. So we use standard form of a quadratic equation to get the parts of a quadratic formula. Okay. Let's see if computer volumes are on. It's not a long one. I already connected the iPad to the Apple TV, so it should play on the speakers above you. Okay. There we go. I don't know why it's not playing on your end. I don't know how to make it louder, sorry.
square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay? So hopefully now when you can't remember it, that little beat will get stuck in your head and you will remember the quadratic formula. Now, as I said, today we're focusing on the discriminant. The discriminant is the part of the quadratic formula under the radical. In the quadratic formula, this is b squared minus 4ac. And the discriminant helps tell me the number as well as the type of solutions in a quadratic equation. There are 3 cases that we are going to investigate while looking at the discriminant. Okay, if the discriminant is positive, then there are 2 real roots. If the discriminant is 0, then there is 1 real root. And if the discriminant is negative, then there are 2 imaginary roots. So again, we have 3 cases where we can have 3 different types of solution sets depending on the sign of the discriminant. So if the discriminant is positive, we have 2 real roots. If it is 0, we have 1. And if it's negative, we have imaginaries. So in example number 1, you want to find the value of the discriminant by finding the number of solutions. So what we're going to do is find b squared. So again, a is what's on your x squared. So in this case, a is equal to 1. b is equal to negative 2. And c is equal to 4. So to find the value of the discriminant, it is negative 2 squared minus 4 times a times c. Any negative number squared is always a positive, so b squared under your radical will always be positive, whether b is negative or positive, because something squared is always positive. So we get 4 minus 4 times 1, which is 16. So 4 minus 16 is negative 12. So it says find the value of the discriminant and then describe the number and types of solutions. So since my discriminant is negative, then this means I have 2 imaginary solutions. Which means that when I plug this into the quadratic formula, I'm going to get a negative under my square root, which means I'm going to get an I in my answer. Which means that if I were to graph this graph would never cross the x-axis. So this would be a graph that is shifted up and does not cross the x-axis. So when you get imaginary solutions, it's telling you that your graph is not hitting the x-axis. It's obviously not the red because the a value is not negative, but again, just kind of showing you examples of imaginary solution graphs. Okay, find the value of the discriminant and describe the number and types of solutions. So it's b squared minus 4a. And in this case, you have to be careful. This is equal to 1. But we know that in order to use the quadratic formula or any of the techniques that we're using so far, we need to make sure that my equation is set equal to 0. So that's really like 3x squared plus 5x minus 1 equals 0. So what that means is when I plug in my c value is negative 1. So I get 25 minus, but this is a negative times a negative, so it's going to turn to a positive 4 times 3 times 1, which is 12. So I get 37. 37 is a positive real number. Therefore, this graph will have 2 real roots. This graph, however, is not factorable, and I know that based on the sign of the discriminant, because if the discriminant is a perfect square, then my graph is factorable. If the discriminant is a non-perfect square, then our roots are going to be between, and it's not factorable. Okay, so once again, it doesn't matter what direction you move the quantities, as long as you move everything to either the left or everything to the right. You're going to get the same value of the discriminant because of the negatives and the b squared. So you have 2 ways you could rewrite this equation. You could say negative x squared minus 10x minus 25 equals 0. Or you could have moved everything to the other side and said x squared plus 10x plus 25 equals 0. And either way, the value of the discriminant will be the same. It doesn't matter which way you move it. So you'd get 10 squared minus 4 times a times c. 10 squared is 100. 4 times 25 is also 100. So you get 100 minus 100, which is 0. Which, if my discriminant is equal to 0, I have 1 real root. That tells me that this factors as something that is a repeated root, meaning this is going to factor as a perfect square trinomial. So that's x plus 5 squared. That's why you only get 1 root, because it is a what we call a repeated root. And this is also the case where your vertex, and again, we have a chapter test, that's why we're going through and kind of talking about all of this again. The vertex is on the x-axis. So this is a case of a repeated root in factored form where your vertex is on the x-axis, which is why you only have 1 real root. So again, if you were graphing that, it would kind of look like that. So again, at this point, everything on that screen is something we have learned in here in Chapter 5. It's all information that I would, anticipate we have obtained. So the whole value or purpose of the discriminant is to help describe the x-axis intercepts. So basically, like what I was just showing you, the discriminant helps us describe those. And again, we have all of our vocab that goes with that. X-intercepts are zeros, roots are solutions, and all four of them occur at the same spot. It's just that how you label them. So a root or solution is always given as an x equals value. Whereas an x-intercept or a 0 is always listed as a coordinate point. So the x-intercepts are always listed as something, 0. And a root or solution is listed as x equals. Whatever the root or solution is would also be the first value of the intercept. So if your root was at x equals 2, your x-intercept would be 2, 0. So that's the difference between the notations. So roots and solutions are given as x equals. X-intercepts and zeros are given as coordinate points. So it says find the number of x-intercepts represents the roots or solutions. So what we're going to do is find the value of the discriminant. So it's b squared minus 4ac so the value of the discriminant is 24. So what that tells me is that my graph has 2 real roots. You could find your axis of symmetry. So my vertex is going to be at -3. -6. And I know that I have a y-intercept, so again, that's my y-intercept. So that means it's to the right 3 and up 3. So that means I also have a point 1, 2, 3 to the left of the vertex. So I can at least give myself 5 points on my graph and see that my graph will in fact hit the x-axis twice. And these are going to be some sort of decimal roots, but that there will be 2 roots. And those roots are occurring somewhere between -6 and 0 for x. We don't have to find the between right now. We just know that it is between them because of the values of the y-intercept and the symmetric properties of a quadratic. Okay, find the number of x-intercepts that represent the roots or solutions. So once again, we have x squared plus 6x plus 10. So b squared minus 4ac gives 36 minus 40, which gives -4. So a -4 tells me I have 2 imaginary. If I have 2 imaginary solutions, then my graph has no x-intercepts. So this graph has no x-intercepts. My y-intercept is at 10. And you could quickly find your vertex. The vertex would represent the min. So it would be at the point -3, +1. And we know our y-intercept is at 10. So we know based on symmetry that we have our other point at 610. And we can see just from that graph, knowing that my vertex is going to be my min at -3,1, that the discriminant does in fact tell me no x-intercepts and is valid. So we can see from the discriminant as well as the graph that we have no x-intercepts, which is no solution. Okay, and last but not least, we have x squared plus 6x plus 9. So once again, we are going to find our discriminant. Which in this case is 0. So that tells me I have one real root. If it's 0, that also tells me that my real root is on the x-axis. It also tells me that I have a perfect square trinomial. So I automatically know that that's a factorable problem. So we should at this point be able to know that that factors as x plus 3 squared. And then if you go back to our unit on completing the square, that's really like saying 0 equals x plus 3 squared, which means that x plus 3 equals 0, or that my roots at x equals -3, which means that I have the x-intercept -3, 0. My y-intercept is at 0, 9. So we also know we have a point 3 to the right and up 9, which means I have a point 3 to the left and up 9 as well. So we can tell that the graph opens up, and we can see that the vertex only hits once. So the discriminant is important. It tells me the number and types of solutions for a graph. Tomorrow when we look at the quadratic formula is actually going to give me the values of the roots. Okay, so the next page in that packet is all about applying the discriminant and being able to tell me what's the value, what does that value represent, and how are we going to use it in the future to tell me the number and types of solutions. Any questions, comments, concerns involving the discriminant? Pretty easy, right? Awesome. Then you have about 15 minutes to get started on that.